I realized that I haven't mastered an objective from way back, which is 5.2, I believe. Um, the parallel and perpendicular components of momentum. And I clearly remember this objective and discussing it a lot in class because you often emphasized how we can break down into any kind of problem into these two components and approach it so much more easily or comprehend it better. So yeah, so I chose 5P48, which basically has a person who weighs 26 kilograms hanging from like a vine, and at the very bottom at this particular instant has a velocity of 12 meters per second, and the length of the vine is 4.3 meters. And then A asks the parallel component of the change in momentum dp over dt parallel, which in this case is 0, because the forces that are acting on this person are not are only in the vertical directions, either upwards like a tension force or downwards Fg, so there's no force that's slowing down or speeding up this person. It's almost like in a uniform circular motion where this parallel component is 0. If you break down the equation, it's essentially d of magnitude p dt times unit vector p, so it makes more sense that because this first part is 0, the entire thing will also be 0. But B asks the perpendicular component of dp over dt, which algebraically you can just sort of break down into the magnitude of p times speed over r, and therefore we can plug in the information we know to get 870 kilograms meter per second squared. I mean, it's asking only for the magnitude of p, so we can simply just calculate it by time multiplying 12 by 26. And then part C is essentially asking the same thing as B, um, and I think it's kind of testing our knowledge of testing whether we know that F net is essentially equal to dp over dt, although the book says that they're not exactly the same. But anyways, you can change the newtons into newtons and say it's 870 newtons. Part D, now since we know the F net, which is 870, we can get, well, here I wrote down as Fn, but I feel like you could express it more accurately perhaps as Ft or Fs. But anyways, so because there is a force downwards Fg of 260 newtons for this person who weighs 26 kilograms, and a bigger force upwards of Fn or whatever you call it, we can find that force, which is 1130 newtons. And lastly, because we know that force, and in this part E we're treating it almost as like a spring force, it's a product of Ks, which is spring constant, with the length of stretch. So since it tells us how to basically calculate the length of stretch, 4.3 minus 4.22, we can get the constant by dividing the force 1130 newtons by 0.08 meters.